Hello, I'm Mr. Dady, and today we're going to talk about mechanical advantage. Alright, we are going to talk about two types of mechanical advantage. First, we're going to talk about actual mechanical advantage, which takes into account friction. Alright, the second one we're going to talk about is ideal mechanical advantage that just neglects friction altogether. So when you're looking at them, it's actual mechanical advantage is AMA. Ideal mechanical advantage is IMA. The IMA, or the ideal mechanical advantage, should always be larger than the actual mechanical advantage, all right, because it doesn't have the friction involved into it. All right, so the first one we're going to talk about is mechanical advantage. Mechanical advantage, actual mechanical advantage, it has a equation, and what that is the resistance force over the effort force. All right. I'm going to abbreviate this as AMA equals FR over FE. All right, just to make things a little bit easier. All right, now I'm going to show you a couple of examples of this. All right, how to do this mathematically. So the first one I'm going to say is I have an effort force of 20 newtons. And I'm going to say my resistance force is 140 newtons. So just like every equation, once you know the two things that you have, you just plug them into the formula. So that gives me 140, which is my resistance force, over my effort force, which is 20. I divide them and I get 7. So my mechanical advantage of this particular effort force and resistance force is 7. And that is how you do it. That's basically it. All right, I'm going to show you another one now. So another example. Let's say our resistance force is 480 newtons. Our effort force is 60 newtons. All we have to do is just plug this into the formula. 480 divided by 60 gives us 8. And that is how you find the mechanical advantage. All right, example number 3. I have a lever. My effort force is here, my resistance force is here. So what is my mechanical advantage? I take my effort force, I put it on the bottom, I take my resistance force, I put it on the top, and I divide. And that gives me 0.6. So my mechanical advantage here is 0.6. That's just doing it from a picture instead of just me giving you it. All right, now we're going to go over ideal mechanical advantage. Ideal mechanical advantage. All right, this is mechanical advantage that deals with no friction. So if the world had no friction at all, that's what this would be. And we need this to figure out the efficiency, which we'll do afterwards. All right, so the ideal mechanical advantage is the effort distance over the resistance difference. Distance, not difference. Or I'm just going to write it as D and dr. All right, now let's do some problems. All right, ideal mechanical advantage. I have an image up here. It's a lever with my effort force and my resistance force. So now we just need to know where those two are at. We don't actually need to know what they are. We're looking for the distance here. So my effort distance is 5, we'll call these meters. And my distance resistance is from the fulcrum all the way to the resistance. So it's 15 plus 5, which gives you 20 meters. And now you just plug it in. So 5 over 20, and you divide, and that gives you 0.25. And there you go. That is how you find it. Make sure you add both of those together to get your furthest one out, whether it's the effort or the resistance. Make sure you just don't use that 15 because that'll be wrong. It's all the way from the fulcrum. Now our second example of ideal mechanical advantage. I have my resistance force and my effort force, but I'm looking for the distances. So we'll do the first one. So my distance of my resistance is 10. We'll call it meters. The distance of my effort is 10 plus 5, which gives me 15 meters. And now all I have to do is plug it in. So 15 over 10 gives me 1.5. And it is unitless. It doesn't have a unit, so just 1.5. And that is how you do ideal mechanical advantage. Now we're going to move on to show you how you do efficiency. Alright, to find the efficiency, you take the actual mechanical advantage, you put it over the ideal mechanical advantage, and then you multiply by 100. Because the ideal mechanical advantage is always greater, this one would be in a decimal, which will give you a percentage. But the ideal mechanical advantage will always be larger. I don't remember what I said. That's always larger than that. Alright, so I'm going to just give you all the pieces for it. My effort force and my resistance force. This is for your actual mechanical advantage. Actual mechanical advantage will always have force, which is measured in newtons, if that helps you out. So your effort force I'm going to give you is 200. The resistance force, I'm going to say, is 2400 newtons for both. So that would be 2400 over 200, which gives you 12. So my AMA is 12, so I'm going to put that first. Now I'm looking for my IMA, ideal mechanical advantage. This always deals with distance. So I do DE and my DR. And let's say it's 15 meters and 1 meter. Alright, now going back to our formula, we'll do 15 over 1, which gives us 15. So I put 15 on the bottom. So my actual mechanical advantage is 12, I put that on top. My ideal mechanical advantage, I put it on the bottom. Now just a quick check. This is larger than that, so I am on the right track. If your ideal mechanical advantage is ever smaller than your actual mechanical advantage, you did something wrong. And now we just divide them. So 15 divided by 12, I already written it down, so it makes my life a little bit easier. Equals 0.8. Multiply that by 100. So 0.8 times 100 gives you 80%. Which, I'll write right here, which gives you 80%. So your efficiency is 80%. And that is how you find your efficiency. I'm not going to do another one because it's a lot of work. So there you go. All right. I hope this helped out, and good luck.